Hello friends, Eli Hibbett here with the Pwn Your Homework Physics Series podcast. If you're looking to prepare, review, or gain an added edge or point of view about topics in physics, then look no further. Tune in each week to unlock your understanding of the physical world surrounding us. And now let's dive right in.
All right, how is everybody feeling today? I'm your host, Eli Hibbett, with the Pwn Your Homework Physics Series podcast, episode 12, titled Another Dimension. Happy Halloween, I just want to say right off the bat. Coming up on Friday, if you're checking this out the day that it drops. Otherwise, happy belated Halloween, but hope you're celebrating on Friday. If not, shame on you. It's a good holiday. Candy, who doesn't like candy? So, yeah. And I hope you're digging the new music. I think we're going to bring my voice back to regular pitch for the intro from here on out, but I thought it was kind of a nice little creepy vibe for the Halloween pod. And I think we might keep the music, though. I like this music. I recorded it myself, so maybe I'm a little biased. But, yeah, I think it gives a good vibe to the whole show. So, this podcast, since it's Halloween week, we're going to kind of stay scientifically oriented, but we're going to take a little bit of a break from kind of the hard and fastidious, material that we've been going through. And we're going to talk about what different dimensions look like. The dimensions that we exist in spatially, and what, 1 dimension, 2 dimensions, 3 dimensions looks like. And then move on to what a 4th dimension might look like. And we have some various metaphors and analogies, since it doesn't exist in our reality. But first, let's get into the song of the week. The song of this week is called Another Dimension by Liquid Tension Experiment. They are a great band, and they are mostly the members of Dream Theater with a new bass player, Tony Levin, and great rockin' progressive instrumental music. So I highly recommend them if you get a chance. But without further ado, here is the clip of the week, Another Dimension. Alright, I think that's going to do it for the clip of the week. Another Dimension by Liquid Tension Experiment. Definitely check those guys out. I have the full song in the show notes. That's from their live in New York City DVD. And, yeah. So that song title will segue us into our topic of exploring the different dimensions. And so I thought we would start with a very simple idea of just a point. And we will use that to describe our world in terms of dimensions. So if we take a single point, you visualize that in your head, it has no length, no width, no height. And so what we call this is a zero-dimensional object. It has no dimension. We can't measure it. It has no length or anything. So the first thing that we're going to be able to measure is something in 1 dimension. So if we take 2 points and we connect them, we have what is known as a line. And this has a measurable quantity which we call length. So now we have our first 1D object, which is known as a line. So we go from a 0D from point to a 1-dimension line. Now, if we take 2 lines that are the same length and space them apart an equal distance, about the same length as the line, and we connect the ends with more lines, we get what's known as a plane or a square. Everyone's familiar with a square. And this is a 2-dimensional object that it has length and width. It has 2 measurable dimensions to it. And so we can keep going, and we go into our 3rd dimension. We take 2 squares and connect the dots, the edges. We get what's known as a cube. Like an ice cube, anything you've seen cube-like. And this is what is known as a 3-dimensional object. So we go from 0D point to 1-dimensional line. Then we take 2 lines, we draw and connect the ends, and we have a plane or a square. And we take two squares and connect them into 3D, and we have what is known as a cube. So we've literally jumped in about, how long is it? About 45 seconds from 0D to 3D. And in the cube we have length, width, and now height is our new dimension, spatial dimension. And so that's it for the dimensions that we live in. We have 3 spatial dimensions and 1 time dimension that pretty much we can use to describe all of our surroundings. But why 3? I mean, we talked about Tesla the other week, and his obsession with 3, 6, and 9. But why wouldn't we have 4 dimensions? And if we did have 4 spatial dimensions, what would that look like? And so people have explored this, and it's kind of a weird thing, but we've actually named what we would do if we took a cube and put it in 4 dimensions. It has a name. It's called a hypercube or a tesseract. And so one way to visualize this is if you kind of continue this analogy of if you took 2 squares and connected the ends to make a cube, kind of do the same thing again and take 2 cubes and connect each edge with a line, the corresponding edges, and you would get what is known as a hypercube or a tesseract. And an easier way to do this is if you took a big cube and a little cube inside of it, you can connect the edges very easy. And so this is kind of a very common pop culture representation of a tesseract, but it's very it's easier to visualize. And so what we've done here is given some context to imagine a spatial dimension that just does not physically exist in reality, which is kind of cool and kind of spooky with our Halloween theme. So one thing I wanted to mention is that we have directions in our world that describe the 3 spatial dimensions we live in. We have a left and right, we have an up and down, and we have a front and back, or forwards and backwards. And people who have thought about what 4th dimension dynamics would be like have actually given names to this motion of forwards and backwards in the 4th dimension, and it's commonly referred to as kata and ana, being the directions that you would move if you were to move back and forth in the 4th dimension. So something that's kind of interesting is, it's very bizarre to think about something in 4 dimensions, and that, it's very easy to realize that this does not exist in our reality. But a 1-dimensional object or a 0-dimensional object also doesn't really exist in our reality. I can't think of anything that I have ever seen that is only 1-dimensional or 0-dimensional. I mean, if you draw a line on a piece of paper, it actually has some thickness, and so it's actually a 2-dimensional thing. And everything that we can describe is usually 2-dimensional or 3-dimensional. You have something flat, and even that's not really 2-dimensional because it has some thickness. But so how do we give a context to something that is 1-dimensional in a world that has no 1-dimensional objects? Well, there's a way to do that, and there is a 1-dimensional object that you can make with a piece of paper and a piece of tape, and it's called a Mobius strip. And so if you take a piece of paper and you cut, let's say 1-inch strip of paper, and you take this strip of paper and you put a twist in it, one single twist, and you tape the ends together, you have what's known as a Mobius strip, and it's actually a one-sided object. It only has one side. And the way that you can prove this to yourself is that if you took a pencil and you draw all the way around, you'll actually come all the way back to the original point that you started drawing on, which is really cool because now you have this 1-dimensional, one-sided manifold in 3-dimensional space, which is rather uncommon. We don't see it every day. So I thought I'd share that with you. And if you wanted to move up a dimension, there's something that's known as a Klein bottle. It's kind of the same idea as a Mobius strip, but with a 2D object. Because we live in 3 dimensions, a Klein bottle actually intersects with itself. But in 4 dimensions, it actually wouldn't intersect. And so people have made 3D representations of a Klein bottle. They have these really cool blown glass Klein bottles, and some people actually knit them. And so if you're interested in what that looks like, check it out. Just Wikipedia or Google search Klein bottle, Klein bottle. Very interesting. Alright, so we've covered some interesting surfaces with 1 dimension and 2 dimensions, and we went through 0 to 4 dimensional, squares, you would say. And so I think one of the difficult things about being able to visualize or even just conceptualize what would happen in a 4D world is that we don't live in one. So the first, feeble attempt, I guess you would say, is to try to just speculate at what you think would happen. But there was this man, his name was Edwin A. Abbott, and he wrote this book in 1884. I mean, what was going on in 1884? This dude had the ability to think like this. And it's called Flatland, A Romance of Many Dimensions. And what it is like a satire or metaphor for how things in 4 dimensions would work, using the analogy of how a 3-dimensional creature would intercept and interact with a creature who lives in only a 2-dimensional world. And it opens up all these possibilities because you start thinking about how we have this fellow, his name is A Square, and he's a square. And he lives in this world Flatland, and you think of how simple of a creature he is. And when you start thinking of things that way, you start realizing that, if there was a real 4-dimensional spatial creature, they would think that the world that we live in is so limited. And the more that he tries to describe the way the square lives and, how he interacts and how he gets around his house, you're like, wow, man, like this dude's life is such a pain in the butt. And it's like so unnecessarily so, because you could just go up and down. And so it starts to make you think a little bit. But so I can give you a little taste of what goes on with A Square. He lives in Flatland. And the way squares look in Flatland, I mean, if you were to look at a square side on, or however you would say, is that he always looks like a line to his friends. And so this sphere from what's known as space comes from 3 dimensions and starts to visit A Square and starts giving him information about this world of 3 dimensions and how he can visualize things. And so he's talking to him outside of the plane of his reality, but he can hear him, and he's like, "Where are you? I can't see you anywhere. Where are you?" And then so the sphere decides that he's going to start interacting with A Square, and he penetrates the plane of his reality. And what the square sees is just a line of changing size. It gets longer and then it gets shorter very quickly, as you would see, if you pushed a sphere through a plane. And he can't believe that this is possible because, how is he managing this? Everybody else that he exists with has a very fixed, length when he looks at them. So he starts to get into all these things that are possible in how a higher dimensional creature would be able to interact with a lower dimensional creature. And one of the interesting things that the sphere is able to do to the square is that he's actually able to very easily reach inside of A Square. And he touches his insides and says, something's like, oh, he tickles him or whatever it is. And he says he can't believe this feeling, and how is he able to do that? And it kind of makes this really weird correlation with our reality, is that in 4 dimensions, we would be open systems, and it would not be impossible to touch our insides. And you would be able to see the inside of our being, even though in 3 dimensions, we look like a nice, tight, compact, closed manifold. So it kind of starts to make you think, and kind of starts blowing your mind apart a little bit as you start thinking what's possible if you were to live in 4 dimensions. So, and then eventually the sphere, he kind of peels A Square off the reality of Flatland and takes him into space and shows him around, and he can't believe what he sees. But it's a really fantastic book, so I definitely recommend checking it out. I mean, you can probably buy it on Amazon, no problem, and or if your library is worth their salt, they have it there. And so definitely get a hold of it. I think it's like 100 pages, but the text is huge. It'll take you like an hour, 2 hours tops to get through. And it's a really gripping read. I mean, you're not going to want to stop reading it. And, kind of just thinking about the parallels you can draw to our life with higher dimensional beings that would interact with us. So that's Flatland, and that is definitely a different look at higher dimensions. So the quote of the week, which I pushed to the end of our little Flatland segment here, comes from Flatland, and it's by Edwin A. Abbott, and it's spoken from the perspective of Mr. A Square. And he says, "I call our world Flatland, not because we call it so, but to make its nature clearer to you, my happy readers who who are privileged to live in space. So think about that. Till ants, crawling around on a leaf who only exists in 2 dimensions, we are highly privileged beings. So keep that in mind next time you're feeling, a little small. So one other little heads up is if you're really into the Flatland thing, there is a movie on the pwnyourhw.blogspot.com blog for this episode. I've included a link to the trailer for it on YouTube, and it looks pretty good. They got some high-profile actors doing the voice work, and it looks like they stayed pretty close to the script, I guess you'd say, with the original book. But I would say definitely get the book first. It's awesome. And man, when you think that this thing was written in 1884. I mean, what did they have in 1884? Nothing. They didn't even have cars. And these people were thinking about higher dimensional beings and their interactions with lower dimensional beings. And the way it's written, maybe they retooled it, but I don't know. It holds up, man. I mean, the language is very fun. The guy's playful, and it's a great read front to back. But I have not seen the movie, so I can't speak for it one way or another. But yeah. So I think that's going to do it for this week, guys. Dimensions. Get into it. It's a good time. Happy Halloween. And I'll see you next time, guys. Take care.